2A, section A. It reads, find the coordinate of the point which divide the line joining 7, minus 5 and minus 2, 7 externally in the ratio 3 to 2. So first, what topic is this? This is coordinate geometry. So let's use this question to quickly review the basic principles in coordinate geometry. So this question may take more than one video. The first video, I will make it 5 minutes. Then next video, another 5 minutes, in order to reduce the space, because I don't know the maximum capacity that WhatsApp will allow us. So, coordinate geometry. So now, what is coordinate geometry? In general mathematics, we are required to learn how to plot graphs. And on the graph, you have the x-axis, which is called the abscissa. Pardon my spelling, please confirm the correct spelling. And then you have the y-axis, which we call the ordinate. And whenever you see co, it means group, 2 or more. So coordinate 2 or more ordinates. That's points on the line. So every point on a line can be described by a distance from the x-axis or from the y-axis. And note, the distance from the y-axis is the x-ordinate, while the distance from the x-axis is the y-ordinate. So let's assume a point at x equals to 2 and y equals to 3. So let's call it point A. So our point A there, with coordinate x1, y1, that is where x equals to 2 and y equals to 3. Alright? So let's take another point. Point B. So here, the distance from the y-axis x2 and distance from the x-axis y2. So this point will have coordinate x2, y2. So in general mathematics, we do this practically, we plot it. But here in further math, we want to avoid the stress of plotting. We want to apply mathematics to analyze all the points on this line without plotting it manually. So, this coordinate geometry has three parts: the straight line, the circle, and the conic section. So here, we are going to review straight lines. So, straight lines. What are the things you need to know about a straight line? Straight line. Every straight line is bounded by 2 points. The initial point, let's call it x1, y1, and the terminal point, let's call it x2, y2. So, what are the things that we should bother ourselves with about this line? First, the length of the line, or distance between points. The length of the line, or distance between points. So to get the distance between 2 points, or the length of a line, the formula is square root of the difference between the x values, x2 minus x1, all squared, plus difference between the y values, y2 minus y1, all squared. That's distance between the point or the length of the line. Then, we also like to know the inclination of this line. How steep or gentle is the line? This can be determined by what we call the gradient, slope, or inclination of a line. Slope or inclination of a line. So the gradient of a line, usually denoted as n, is the difference between the y values, y2 minus y1, over difference between the x values, x2 minus x1. Then you can relate this to the angle of slope or angle of inclination. So angle of slope or inclination. You can get this from equating the gradient to tan theta. Now there is something I need you to know about slope. If the line is horizontal, it is a line of y. So let's say it passes through its point y equals to a on the y axis. So it's line y equals to a. And for horizontal lines, there is no change in y. Hence, the slope is equal to 0. If the line is vertical, it is a line of x. So let's say it passes through a point x equals to b. So this line, its equation is x equals to b. Along this line, there is no change in the value of x, but the change in value of y is infinite. It can vary. So remember, slope is change in y over change in x. So since change in x is 0, anything over 0 is what? infinity. So for vertical lines, the slope is infinity. But for inclined lines, the inclination can be positive or negative. So if the line is increasing, the general form of the equation is mx plus c. We'll come back to that. But the gradient of this is said to be positive. That's an increasing line. But if the line is inclining downward, if it's inclining downward, the equation is still of the form mx plus c, but here the slope is negative. So this is where we'll stop video 1 on this. I'll continue video 2 shortly.